Hey everyone, geophysicist Stefan Burns here with an important astro update for you. We discovered a comet on January 13th of this year, 2026, which could become one of the great comets of this century, perhaps even of all time. That is no joke. This is Comet C2026A1 MAPS, and well, it comes from the Kreutz sun-grazing comet family, which is a family of comets and cometary fragments which pass very, very close to the sun, meaning it gets very, very bright. And well, other members of this sun-grazing comet family have put on spectacular shows, becoming some of the greatest comets ever observed. For example, the Great Comets of 1843, 1882, Ikea-Seki Comet in 1965, and Comet Lovejoy in 2011. And what makes this comet special, C2026A1 MAPS, is the fact that it was detected so far out. Never before has a Kreutz sun-grazing comet or comet fragment been detected as far out as this one. Now, we do have really good observatories nowadays as compared to, let's say, 1965. But in general, the further out something is discovered, the larger it is. And the larger a comet is, the more likely it's going to survive that perihelion, meaning it could get very, very bright, have an incredibly long tail, and that could be visible even during daylight conditions, though under very specific time windows when the sun is setting, because it's so close to the sun, better viewing from the southern hemisphere. But this will likely get brighter than Venus, which is the third brightest object in our sky, only behind the sun and the full moon. So this is Comet C2026A1 MAPS, here imaged by James Webb on the 7th of February. We see that it looks like has a fairly well-defined nucleus. It already has a tail. It's coming in fast. Its eccentricity for its orbit is nearly 1. So we think it comes from the Oort cloud. It's so close, though, to having a hyperbolic trajectory that it could have been almost classified as an interstellar object, but it does seem to have come from this Kreutz sun-grazing family, and as a result from the Oort cloud, this hypothetical reservoir of comets and icy bodies and more, and it'll perform that perihelion on the 4th of April around 1400 Universal Time. So there's a lot to talk about in today's video, how it could become a great comet with a spectacular tail and become very, very bright. Could also impact the sun. Let me show you this really quick. We see this comet impact here. This is a comet that flew into the sun in 2011. Look at how right after that impact we get this massive coronal mass ejection. So these sort of dynamics are at play. I'll describe the physics of this in just a little bit, but if it did impact the sun, there's some evidence that it might. We could be looking at a significant space weather event as a result. To begin with, let's look at the apparent magnitude of Comet C2026A1 MAPS thus far based off of astronomical observations. And so we're looking at the brightness of this comet. We see that it's still right now quite dim. You're not going to see this unless you have good equipment like a nice telescope, but it is brightening rapidly. And we have the projected light curve for this. Since we've observed so many comets across time, we can calculate out what its brightness is likely to be near perihelion. There's some equations for that. And we see that it gets all the way here to about negative 7.5. Now, you start off in positive values for apparent brightness. That's dimmer, and then once you cross 0, you're into negative values, and that's actually brighter. So it seems a little counterintuitive, but every increase of 1, let's say going from 13 to 12, or let's say 5 to 4, that is a 2.54 increase in brightness. So as you start to scale up, that really amplifies. 2.54 times 2.54 times 2.54, you get the idea. It really goes up quickly. So Venus has a maximum brightness of about negative 4.4. The sun is around negative 22 or something like that. Super, super bright. So it's not going to get brighter than the sun. It's not going to get brighter than the full moon, though it could have a tail that stretches across quite a lot of the sky after perihelion. But it is expected to get up to this range there if it survives its perihelion, being negative 4, negative 5, maybe negative 7.5 in brightness. We'll have to actually wait and see. This is a calculation. What the observations will give us is a completely different story. Could fragment apart before perihelion. That is a possibility. Personally, I don't think it's going to. I think we're going to see something really, really incredible, but we'll have to wait and see. But then after this sharp spike in brightness, it will diminish as it then flies away from the sun if it survives that perihelion passage. Let's look at Comet Lovejoy in 2011 to see how it survived its perihelion. The last significant member of the Kreutz sun-grazing comet family was Comet Lovejoy in 2011, and here we can see that with our coronagraph imagery from December of that year. Comet Lovejoy flew in very close to the sun, performing its extremely close perihelion, then flew out, and in fact it did break up, though it still gave us quite a show afterwards, though eventually it did effectively diminish. So it didn't fully survive its perihelion to come back for another round. At least we're not expecting Comet Lovejoy to return. But we can see how these comets can get very, very close to the sun, and they'll get very, very bright. And that's the last significant comet from the Kreutz sun-grazing family that we've had. Before that, the Great Comet Ikea-Seki in 1965 gave us quite a show, reaching very, very bright apparent magnitudes visible during daylight. Really surprised some people when they saw it in the sky for that brief limited time window close to the sun. And while we could see that from Comet C2026A1 maps, but it could also impact the sun, and there is some indication that that could occur. Let's check it out. Here we have our 3D solar system viewer provided by NASA JPL, which collects all the latest astronomical observations on comets and small bodies and asteroids and planets and more to calculate their orbits. And we can look, before we zoom in on this, we can look at the small body database right here for this comet, and we see that its last observation and then solution date was the 13th of February as I'm recording this. So it has up-to-date information. This is the absolute latest information for Comet C2026A1 maps, and then they use that to plot this 3D visualization. Well, let's zoom in here on this, and you'll notice that the orbit of this comet actually intersects through the sun. So I'm not sure if this is just some sort of visualization error or whether this is the actual precise orbital calculation. But as of this moment in time, it's projected to fly through the sun. Now you'll wonder why the sun is offset from the exact center of our solar system. That's because that's the barycenter. The sun orbits around the barycenter. But this comet very well could impact the sun, and well, we've seen that before. Let's check out this other comet from 2011 that impacted into the sun. This is crazy. Here we see this comet back in September and October of 2011 impacted the sun, and then we see this massive coronal mass ejection immediately afterwards. And just about one or two of the astronomers and physicists that run the SOHO chronograph team and all that were like, yeah, this could be related. Most of them just immediately brushed it off. Don't ask me why, it seems pretty obvious to me. And especially the physics helped to confirm that. So you have to consider the physics here. You have this, this object flying in, which is made up of ice, it's made up of rocky material, and it's kind of fused together, but it's not that strong and coherent, right? You know, there's probably a little bit of metal there as well. It's very possible. And you have to remember that the sun has the gravity, basically, of the solar system. You know, the majority of the gravity from the solar system is generated by the sun. And as you get closer and closer and closer to the sun, you're going to accelerate more and more and more. So your kinetic energy is going to go up and up and up. And well, there's something known as the critical velocity, which is if something is traveling fast enough, it will actually ionize. So elements and compounds have a critical velocity at which if they travel faster than that, they basically just actually ionize into plasma, charged ions that have either electric, negative or positive charge. Therefore, they are now under the influence of the electromagnetic force and not necessarily that of gravity. So here's one of those intersections between gravity and electromagnetism. Is so interesting. Electromagnetism being a force that is so much stronger than gravity, 10 to 36 0. So the moment you are electromagnetic, gravity effectively does not have an influence over you, you could say. Well, this comet is coming in very, very fast. As we can see, let's pause it at the right time because we're going to see how it starts to spread out right here. It's clearly already breaking apart and fragmenting to some degree. And as that surface area to volume ratio increases, then you have that critical velocity. This is traveling super, super fast. It's going to ionize into a plasma. It's also coming in on the sun's far side like this, okay? So though it's just 2D flat, this imagery, it's actually coming in at an angle on the sun's far side, and then it hits, and then we get that coronal mass ejection on the sun's far side. Now what happened is this effectively turned into a bunch of plasma. And what we see with the sun is that it has very structured electromagnetic fields. So it has these loops, these magnetic loops, which we call them coronal arches or coronal loops. And a sunspot can have a very strong magnetic field on the order of 1,000, 2,000, 5,000 Gauss. Very, very powerful. And if you have disruptions to that magnetic field, that can then trigger solar flares, and that explosion can cause a coronal mass ejection, a release of plasma. It's like a trigger mechanism. So you're not actually seeing this comet like just a rock impact the sun. Of course, that rock's gonna be very tiny. The sun is massive. What you're seeing at the very end here, I'm gonna put this back on loop. What you're seeing at the very end here is that this comet vaporized into plasma, and now it's under the electromagnetic force. It's immediately routed by magnetic fields to very specific junctures, and that flow of plasma through that being introduced from the outside, being a foreign introduction of plasma, for example, caused there to be an energetic surge which destabilized whatever structure it flowed through, causing there to be that solar explosion, like a trigger mechanism, like a domino effect, and then you get that release. So the physics of this makes perfect sense. You can't just think of it just being a rock hitting the sun. It's really about plasma interactions. And when you have a high amount of plasma or particles pass through electrostatic double layers, which these sort of plasma coronal loops and arches form, that surge can cause there to be these solar explosions, and then you get solar flares and coronal mass ejections. And you can read more work by Hans Alvin if you want to understand that. His book, Cosmic Plasma, he talks about that quite a lot. So we saw a clear example in 2011, same year as Comet Lovejoy, of a comet impacting the sun, and from what I can tell, creating this coronal mass ejection. And we have potentially this dynamic coming on April 4th if the comet is to survive fragmenting before then. And if it actually does impact the sun, we could have quite a significant solar event unfold, because again, it was detected super far out. So there is some indication that it's quite a large piece of, of either the Kreutz sun-grazing comet fragments or, one of the larger cometary bodies in that group. If we look here for any indication, and we kind of just go forward 1 hour at a time, we see it comes in on this side right here. So it's coming in there on the left, let's say. If we zoom out, this is directed out towards Mars, opposite side of Earth. So in this scenario, if this plays out, the coronal mass ejection, if that was to get triggered, looks like it would go out the other way to the far side. But we're still so far out, it's really pretty much impossible to say what's going to happen, whether it just kind of vaporizes before perihelion, it survives perihelion, becomes a great comet, or whether it actually impacts the sun and triggers something significant in terms of space weather. So that's your astro update for today. I'm going to keep you up to date on Comet C2026A1 maps, because I think this is going to be quite a significant astronomical event. Whether it impacts the sun or becomes a great comet, I think those two outcomes are the most likely. I don't think it's just going to vaporize, but we'll have to wait and see. So just check in on the channel, subscribe, and you will be informed. There's going to be a lot of talk about this, I'm sure, in March. So keep up to date with everything that's happening with the Earth energetically by following and subscribing to the channel. We cover earthquakes, volcanic activity, severe weather, and geomagnetic storms, solar activity, space weather, planetary resonances and alignments, interstellar and cosmic forces, and so much more. I present videos almost daily. Thank you so much. Please smash that thumbs up button to help the channel grow, and I hope to see you all around in future videos. I'll be back with more updates soon, and have a great day. Till then, thanks so much, and see you soon.